Hey everybody, great to be here today. My name's Lance. I'm going to talk to you a little bit about Vert.X today. I work for Red Hat on a team called Project Odd, which is part of the JBoss division, and we're tasked with doing kind of R&D efforts in the sort of polyglot world of the JVM. And Vert.X is one of those projects. I'm really excited about it. I should start by probably saying Vert.X itself is not necessarily a tool for handling big data, but there's a lot of things that you can do with Vert.X that might provide some benefit to your big data environments. I think so anyway. I hope you get something out of it. Before I start, anybody here ever heard of Vert.X before you read about my talk or came to the talk? Great. Anybody played with it at all? A little bit? Anybody have anything in production? Nope. Okay, good. Well, hopefully you'll learn a lot today. So let's talk first about what Vert.X is. This is from the website Vert.X.io. Vert.X is a lightweight, high-performance application platform for the JVM that's designed for modern mobile web and enterprise applications. That sounds pretty impressive, I guess. But I don't really know what that means. Is this too loud? Is that me banging around there? That's good? Okay. I think I can break that down into three really simple English language words. It's small, and it's fast, and it's really buzzwordy. So let's look at each one of those in turn and see if any of those things make sense for you in your environment. First of all, it's small. Vert.X is a lightweight, high-performance application platform for the JVM. What do I mean when I say it's lightweight? Well, at the base level, just the file size itself is really pretty small. If you want to download it and play with it, it's less than 5 megabytes to do that. The core Vert.X API and the platform itself are really nice and tight. I feel like I keep banging something here. It's that. It's so loud. Okay, so nice and tight. Because of the small size, it's embeddable. So you don't necessarily have to be using the Vert.X platform and deploy your applications using Vert.X if you don't want to. Or if you, let's say you have an existing Java application over here and you want to start playing around with Vert.X somewhere else in your network, you can get those two components, those two applications to speak to each other by just embedding Vert.X into your existing Java application. So that's kind of nice. Part of the reason that Vert.X is really small is that it's modular. So as I said before, the core API is really nice and tight. There's not a lot of extraneous functionality that's provided by, that's like magic, not a lot of extraneous functionality provided by sort of extended APIs that do all kinds of fancy things. The APIs for Vert.X are really constrained primarily to networking operations, file system operations, and that sort of thing. So if you want to do something a little bit more complex with it, like let's say write a web server that serves files off the file system, you might do that as a module. And modules you can then package up and other people can use them, or you can use them in multiple places in your application development environment. So that's what I mean by lightweight. How about high performance? First of all, I should say before we talk about performance that benchmarks are, they should always be taken with a grain of salt. A benchmark environment is never going to replicate your application environment. It's not necessarily always going to sort of simulate the needs that you have necessarily. So anything that I say here, if your application really demands some very high performance stuff, then I highly recommend that you do those own benchmarks yourself. But that said, Vert.X is capable of handling hundreds of thousands of responses, request-response transactions per second with a basic HTTP kind of GET request, which is pretty nice. Part of the reason it's able to do that is that it's built on Netty. Anybody here heard of Netty? Great. Netty is a fantastic asynchronous networking library for Java, and it's very performant. It beats out Vert.X in these benchmarks, actually. And it's used by a lot of big players. Twitter has been mentioned a lot today. There's a good blog post this month on the Twitter blog about their use of Netty 4. So Vert.X takes full advantage of Netty's asynchronous capabilities to provide something that's almost exactly as performant as Netty itself. Netty, as I said, is asynchronous, What does that mean when I talk about asynchronous? Most of you are probably familiar with asynchronous APIs. I mean, if you've done anything like write JavaScript in a browser, well, no, that's further on. But asynchronous APIs, the idea behind them essentially is that, I've got some task that I need to perform and it's going to block. So I want to ask the API to perform that task for me. When that task is completed, I'd like the API to notify me in some way. Typically that's done with a callback function or some handler class that you pass in, depending on the language. But the idea behind it is that your code can get back to doing the stuff that your code was designed to do and not sit there and wait for a file to be opened or a write to happen on a network socket or something like that. And to put just a little more clarity around the hundreds of thousands of responses per second, I think partly because of this asynchronous nature of Vert.X, we're seeing in the most recent benchmarks about 500,000 responses per second, which is nice and fast. The asynchronous API that Vert.X provides covers the gamut of lots of things, but primarily we're looking at networking operations, so you can read and write to raw sockets. There's also a higher level abstraction for the HTTP protocol, as well coming soon, and I think it's actually out as of yesterday in like a milestone release, UDP and DNS asynchronous APIs. And then all the file system operations that you might expect that would typically block are provided as asynchronous APIs in Vert.X. And then finally there's the event bus. And the event bus is kind of the core of Vert.X. Vert.X is built on this actor-reactor pattern. So things are put on the event bus, and interested parties, as those events occur, are notified by a dispatcher within Vert.X. And the event bus makes a lot of things possible with Vert.X. And we'll talk a little bit more about those later. But I want to keep going with this quote about what Vert.X is. So Vert.X is a lightweight, high-performance application platform for the JVM. And it sounds like, at least my experience here today so far, a lot of you people are familiar with or writing Java code anyway, so I don't have to explain too much about the JVM. But I thought this was an interesting quote by a colleague of mine at Red Hat. A long time ago when they were building all of these locomotive engines, initially all of those train engines had rail gauges that were specific to the engine, but eventually everyone realized that it made a lot more sense to have a common rail gauge underneath on which all these engines could run. And that's kind of how I think of the JVM. It's this common rail gauge upon which lots of things can run, specifically a lot of different languages. And in the case of Vert.X, these are the languages that Vert.X supports. So if you want to write an application in Vert.X, you can do that in Java, you can do it in JavaScript, you can do it in Clojure. Not all of these are full release at this point, but they're all available. They may be in a beta form. But that's pretty nice. And you can also mix and match. So if you've got components of your application that really are most appropriate in Clojure, you can write that bit in Clojure, and then you can write your web server in Java if you want to. And I'll show you some examples of that. On our team, we call this the polygasm. So the interesting thing about, one of the interesting things about the different language modules provided by Vert.X is that they all have this API that's identical in functionality to the core Java language API. There's really no difference. You can achieve whatever you need to achieve in JavaScript that you can achieve in Java or Clojure or whatever. But each of the APIs has their own kind of language-specific semantics. So in Ruby, you're dealing with blocks. In JavaScript, you're dealing with anonymous functions. And Java, you're dealing with classes and interfaces. What's really neat about these language APIs or these language modules is that they're just like any of the other modules. So all you have to do is provide a little bit of extra configuration, implement another file or two, and boom, you can run your application in. This is just a list I grabbed from Wikipedia of kind of all the known languages that not all the known languages, a good set of languages that run on the JVM today. So if you wanted to write your Vert.X application in Scheme, you could do that as long as you implement a language module for Scheme. And then you don't have to do anything else. You just tell Vert.X where that language module is. It'll download it, and away you go. So that's kind of neat. All right, here we get to the really good stuff. Modern Mobile Enterprise. It's a high-performance, lightweight application server for the modern mobile web and enterprise applications. Okay. I'm not sure really what that means. I think we can probably take a look at some of the characteristics of modern applications to determine what you might expect from something that is designed for modern mobile web and enterprise applications. Those kinds of things would be concurrency, obviously. If you're dealing with 500,000 request responses per second, you definitely need to be concurrent, but we have to consider thread safety. Asynchronous, or this kind of reactor pattern, is a big thing these days, and the kind of thing that you're seeing in a lot of these sort of mobile applications on the back end anyway. Client push is a big thing. You want to be able to get data out to handheld devices or browsers, if that's the case. Node.js is a big thing these days. It's the hotness. The reason this is marked out is because, well, I guess you don't have to use a Node.js application to be a part of the modern mobile enterprise, but I don't know, the kind of patterns that Node.js puts out there are sort of the patterns that Vert.X works with, right? Similar in a whole lot of ways. There's some distinct differences between Node and Vert.X. We might look at some of those, but the idea is, something kind of lightweight, asynchronous, and then of course you need to have flying rainbow unicorns for your modern mobile enterprise. All right, so that's kind of the brief overview of what Vert.X is. Next, I want to just look at some code. We'll do kind of a flyby of the API and talk a little bit about how Vert.X works, and then I'll show you a sample application that I wrote for this presentation. All right, so this is a little bit of JavaScript code, and this is a full-on Vert.X application right here with more comments than actual code. And what we're doing here is we're using the require statement to pull in the Vert.X container. The Vert.X API comes in two pieces. You've got Vert.X Core, which provides all your networking and file system operations and that sort of thing. And then you've got the Vert.X platform, which provides mechanisms for manipulating Vert.X itself, deploying modules, deploying verticals, and that sort of thing. Here, this is just a standard JavaScript object with some configuration information. And then I'm going to use this container object to deploy a module. And this is the module I'm deploying. It's called Mod Web Server. This is the naming convention for Vert.X modules. There's kind of a group name, which, if you're familiar with Maven, looks kind of like that. There's a tilde separator, the name of the module itself, and then a version number. So I'm asking the container, deploy this module on my behalf, make it part of my application, and it does so. And this is just a little web server module that, as I said, there are HTTP abstractions as part of the Vert.X API, but it doesn't necessarily know about what your document root is and serving files off of the file system and stuff like that. It really just deals with HTTP protocol itself. So as a module, there is a mod web server which can take a little bit of configuration and do things like serve files off of the file system asynchronously. And this actually is the first few lines of code for the application that I'm running right now for this presentation. I wrote the presentation in reveal.js. I just needed a web server to serve up the files, and so that's what this is. There's more to the application. When we get to the demo, I'll show it to you, but this is the first, dozen lines of, or not even dozen lines of my application here. Here's some more code that might be slightly more interesting. This time it's in Java. Where in Java you extend a class called vertical, and the vertical has a member variable called Vert.X upon which the API hangs. And here you can see that we're creating an HTTP server. It gives us a server object back. And then we call this request handler method. And the request handler method isn't really doing anything other than just saying when a request comes in, here, take this anonymous handler class that I'm sending you, and call this handle method when a request comes in and give me the request object. So when the handle method is called, I can take that request object, get the response from it, do things like set status codes, and write out status messages right to the body and the response. And then down here at the bottom, I'm calling server.listen. So really simple HTTP server that always returns the same thing, too many gerbils. But what's kind of neat is that I can write that exact same application in JavaScript. So here's the same thing, just with JavaScript idioms in use. Instead of passing in a class, we're passing in an anonymous JavaScript function. But it really doesn't look any different. Here it is in Clojure, doing exactly the same thing, but this time with a lot more parentheses. Right. I was just making a joke. and here's JRuby with a lot more underscores, which are also not required. So, okay. So JRuby. So there's an example, or four, I guess, examples that are all doing exactly the same thing, all running under the same platform, all using a different language. Kind of neat. I've mentioned the word vertical, or at least you've seen it on my slide earlier. A vertical is just a name for the unit of deployment, or not the unit of deployment, the unit of code that Vert.X runs. It's kind of the entry point into your application. So a vertical can be just a plain old JavaScript file, and you can run that. It can be a Java class. And you run them by just using the Vert.X command line, Vert.X run, give it the file name. You can give it some configuration options. In this case, it's a JSON file. JSON is kind of the lingua franca of Vert.X. And then you can specify a number of instances. So if it makes sense for your application to spin up multiple instances, Vert.X will handle that for you and assign each one of those instances to a different processor core. We saw earlier that I could deploy modules programmatically. Well, it works exactly the same with verticals. Here's an example of using JRuby to deploy a Clojure vertical. Pretty simple here. So how do verticals work? What are they exactly? What happens when you fire up a vertical? Well, you know, Vert.X is this kind of reactor pattern thing, so the event loop is central to it. And when you fire up a vertical, it is assigned to one and only one event loop. So anytime code is executing in your vertical, it's executing on that event loop. Each event loop in Vert.X is assigned to one and only one thread. So now you know that your code is always going to be running on the same thread because it's always running on the same event loop, and that event loop is always on the same thread. And each thread is assigned to a processor core. When Vert.X spins up, it looks at how many processor cores you have and tries to optimize. And what this buys you basically is thread safety, because your code is only ever running on a single thread, but it's got an amazing level of concurrency, and it doesn't compromise your cores. It doesn't leave cores sitting there doing nothing, basically. So the event loop. Event loops are a really powerful design pattern, but there are some things that you need to be aware of if you're writing code that runs on an event loop. First of all, you cannot block the event loop, because the way it works is, you know, events are happening, they're getting put on the event loop, a dispatcher takes the results of that event and then hands it off to whatever interested parties, your callback functions or whatever. And if your callback function is blocking, the dispatcher's waiting for that blocking action to complete. And so none of these other events that are piling up behind you are getting executed at all, or getting handled. So sort of the key number one and only rule that you really need to think about when you're writing Vert.X applications or anything that really lives on an event loop is don't block it. The kinds of things that might block the event loop, any of that Java concurrency stuff like thread.sleep, object.wait, countdown latch.await, you really want to stay away from those things. You also, I mean, you really never want to do something like that, but you don't want to sit in an endless while loop. You can't even do things like heavy processor utilization where you're calculating the nth digit of pi. And then obviously big database queries or even small database queries. those are going to block for some amount of time, and that's going to reduce your performance. So, what do we do? Well, like I said, Vert.X has all these asynchronous APIs that you can take advantage of in order to not block. In this case, this is an example of the file system API where I'm pulling in the Vert.X file system, and then I'm just opening a file, and I can do whatever I want with that file because it's not blocking. It doesn't matter. I'm all good. But that doesn't really help us, right? I mean, what about databases? What about calculating pi? I mean, there are applications where that kind of stuff needs to happen, obviously. You're talking about big data. You're probably going to do some heavy-duty data transforms. That takes a lot of time. What's the answer for that? Worker verticals. Worker verticals are part of Vert.X. They kind of live off onto the side. They're the bad stepchildren. They do things like blocking, but they're incredibly useful. They don't run on the typical event loops that all of your other verticals are running on. They do only ever run on a single thread, so at any point in time your code is running just on one thread, but it's not always the same thread. Vert.X basically just pulls whatever threads are not doing anything at the moment and runs those worker verticals on those threads. So you've got to be careful about things like thread local memory and stuff like that, thread local storage. But the real key thing about worker verticals is that they can block. So you can do things like a worker vertical, write a worker vertical for your Postgres data, and then when your front-end vertical needs to access that Postgres data, it uses the event bus to send a message to your worker vertical saying, hey, give me this select. The worker vertical returns those selects as another message on the event bus, and it's all happening asynchronously. So I've mentioned modules a couple of times. Really, modules are just kind of the unit of deployment for Vert.X. So, you know, an application is never really a single file. I mean, I guess it could be, but most applications out there have got resources and all kinds of other stuff, different libraries that they need to pull in. And you typically organize those in your project directory in one way or another. Modules are just a way to name that project directory. Zip it up into a zip file, give it a specific name, give it a little bit of JSON configuration to tell Vert.X, you know, what it is and what the entry point is, and away you go. Vert.X provides a module repository where there are a lot of existing modules out there, both developed by Vert.X core team itself, as well as you know, different members of the community. And you can find a lot of really good stuff. I'm using two modules in my demo application today. We saw one earlier, the web server module, and I'm using a MongoDB module to deal with back-end database persistence. So I'll show you that in a minute. Let's just fly through the API real quick. You're not going to see all of it, but just kind of the big top-level sections. We got a container API, and I've mentioned this before. You can do things like deploy a module with the container API, and here we're deploying that web server module. And again, this is JavaScript. Did I say at the beginning, I maintain the JavaScript language modules for Vert.X, so most of the examples you're going to see today are in JavaScript, because that's what I write all day. But all right, so it's a JavaScript vertical. It's deploying the mod web server module that's written in Java. And let's say in our organization, all of our database stuff historically has been done in Ruby. So I'm going to write my little worker vertical in Ruby, and I'm going to call that database cruncher, and I'm going to deploy that. And then I'm going to deploy a vertical, kind of the front end piece that's a closure app. So JavaScript, deploying a Java module, a JRuby worker vertical, and a closure vertical. That's polyglot for you. File system, we saw this little bit of code before. Basically, Vert.X provides all the file system operations that you might want and expect. Move, copy, delete, open, write, whatever, and all of those are asynchronous. The networking API, again, provides raw socket access, so you can do things like write directly to a socket, or if you want to deal with these HTTP abstractions, you can do that as well just by using an HTTP server provided by Vert.X. Because you can't do things like thread.wait or thread.sleep, you know, Vert.X, well, for a number of reasons, but that's part of it. Vert.X provides a timer API, which is pretty simple, but really useful, comes in handy a lot. You can do things like set timers. In this case, we're setting a timer to execute this function 5 seconds in the future. 5 seconds in the future, the console gets logged with this message. These functions return an ID so that at some point in the future, if we wanted to cancel it, that would be possible. And then there's a set periodic function, which allows you to do essentially the same thing. It waits for, in this case, 2 seconds, then it executes the function, and then it'll wait 2 seconds and execute the function again ad nauseum until you cancel it.
Does it get put in the same event pool?
Pardon me?
Do those timeouts get put in the same event pool?
Yeah.
Okay, so that is sequential then? To the other?
Are they sequential?
Because something else waiting on that 5 seconds, or is it just part of something?
Well, that set timer call returns immediately. Maybe I don't understand your question, but the set timer call returns immediately. So what we would see here is, we'd set timer, then set periodic. The first thing that would come out is this, attention, here comes the loudmouth. Then we would cancel the, maybe I'm not understanding your question very well.
Okay, so if you set the timer, you need to allocate something to calculate what the time is passed, right? That's probably something not a thread or something.
The thing to count how much time has passed, Vert.X takes care of that for you internally. The dispatcher handles that. And that counting probably does happen on a separate, yes, it does happen on a separate thread. Otherwise, it would be blocking. But that's transparent to you. You don't need to be aware of that. Yeah?
Your example there, the cancel timer, won't that execute before either the two pop?
Yes. It will. And so it will cancel this timer, but this one will continue because each timer has its own ID. So we'll never, in this little sample code, we'll never see I'm 5 seconds in the future, but we will see every 2 seconds, I shout every 2 seconds. And then here's the event bus, and the event bus is kind of the core, the heart of Vert.X in a lot of ways. The event bus provides a way for you to communicate messages between different components of your application, as well as different applications in the same JVM, and also different verticals running on different nodes in your cluster as long as they're on the same local network. There's this kind of transparent, happens automatically clustering, so that every node on your local network is part of a meshed event bus. And the way the event bus works is very simple. Excuse me. The first thing we can do is grab a handle to the event bus by requiring the Vert.X event bus module, and then register a handler on it. And the first parameter here to this function is a string, and it's basically just a channel name. It's the channel that we're interested in. So when I register a handle on a channeler, what I'm saying is, hey, Vert.X, when a message comes to this channel on the event bus, notify me. And notify me by calling this function that I'm giving you. So anytime a message comes to app.message, my function here gets called, and I log a little message here to the console, and then I also get a reply object, which allows me to reply directly to the person or process that sent that message. And then in terms of sending messages, there's 2 ways you can do it. You can publish a message by sending it to everyone. So in this case, hey, everybody gets sent to every single bit of code that has registered interest in the app.messages channel. And then there's send, which will send it to one and only one recipient, and that's handled by Vert.X on kind of a round-robin basis. And here in this case, we're getting a reply back. So that's the event bus. Allows you to pass messages between components. The kinds of things that you can pass between components, I mean, I just showed strings in that little example there. Basically any kind of scalar strings or numbers or whatever, or JSON, which can be really useful. And then, like I said, it can your communication can happen between different components in an existing application, a single application, different applications or different nodes on a single cluster. And this looks like a repeat of that slide before, but it's not. This is the event bus, but in this case, we're utilizing the event bus on the client side. So if you can imagine, my web browser has loaded up this JavaScript file from the server. It's called Vert.X bus.js is the JavaScript file, and it comes with the Vert.X download. And now I can get a handle on this Vert.X event bus directly in my browser client, which allows for some really amazing things. I can communicate with my back end directly through the client over the event bus, and vice versa. Messages can come from the event bus directly to my browser, and that's where we get into the browser push kind of stuff. So here we're just doing the same thing. We're registering a handler. When a message comes into app.messages, we log it to the console, and then, as an example, we're sending it. So that's what Vert.X kind of is overall. Quick look at the API. Let's look at a demo. Politics were in the news a lot lately, and I felt like all of the politicians that I was reading about were a bunch of clowns, and I thought that it would behoove us to get them all out of office and vote some folks in that would probably do a better job. So here's our ballot, and it's really simple. I've opened it up in two different tabs so you can see what's happening here. Right now it looks the same in both tabs. And you can just click on a person's face to vote for them, right? Pretty nice. And you can see that in this other tab, it's registered there too. I can leave a comment. And it's automatically, shows up here, but it also shows up over here. And then I can go over to my Mongo. This is all happening in Mongo, and I can find my candidates, and I can see that, oh, now actually when I first started, well, I did this find before I actually cleared out the database. But this second find, it reflects the data that we're seeing on the front end. So the data is not only being shuttled around between different browsers, but also between the back end and my browsers. So, Charlie Chaplin's got 5 votes, Marcel Marceau has 3, and Buster Keaton has 7. And I like Buster Keaton, so I'm going to give him some more. We'll go back here and see that now he's got 13 votes. So that's kind of neat. How does that work? Let's just take a look at the code here real quick. Where is it? Okay, so we saw this little bit of code in one of my slides earlier. I've added a little bit to this here, but basically this is our web configuration for the mod web server module. I've added a couple of configuration options. This bridge option right here is what makes all this event bus stuff possible. Basically, I'm telling the web server, open up a sock.js bridge and wire up the event bus so that it can work seamlessly between the client and the browser. You can do this manually if you're not using the mod web server module. That's how the mod web server is doing it. And then inbound permitted and outbound permitted. This is not a very secure application. These are just filters that allow me to filter what information is passing across that bridge, whether it's going into the server or out to the client. In this case, everything is okay. So deploy that web server module, and then I've got this function setup demo data, which it's got a bunch of data here. It starts with 0 votes. And I use the event bus to send a message to Mongo config, or to the Mongo database. And the action is delete. I want to delete all the candidates, and I want to match every single one of them. And because this is asynchronous, if I were to just then immediately afterwards start adding these things back to the Mongo, it would not really work. Not all the stuff would have been deleted by the time I started adding things back necessarily. So this callback function here as the third parameter to my send call is the callback function that gets executed once that send has completed, once that operation has completed. And so now I'm just going to add this demo data back. And then I use a little bit of JavaScript object here to set up some configuration for my Mongo module, which is also, this one is another one that's maintained by the core Vert.X group, mod Mongo persister. And it just uses the event bus to send messages back and forth about creating, reading, updating, deleting records in Mongo. The final parameter here in the function call for deploying the module is setup demo data, and that's this function that we saw up here. So once the module has been deployed, that function gets executed and we're ready to go. So on the back end, that's the entirety of my application, other than Mongo. What does it look like on the front end? Let's do it this way. So I've got a little debug output here because I want to show you some hacks here in a minute. Basically, the HTML is really simple. All the HTML is doing is, what's happening here? I knew if I did a live demo, things would go wrong. Okay, the HTML is very simple, and all it does is have this div here for a candidate list, and it's using an _JS template to fill in the candidates as that data is received from the Mongo database over the event bus. That's really all that's happening in here. I'm loading up a bunch of JavaScript files. The one that we care about the most is ballot.js. That's the file that's doing all of the synchronization between Vert.X and Mongo, or sorry, between Backbone and Mongo. So the candidates that you see here, these are just Backbone models, Backbone.js models, basically just a JavaScript object. And Backbone is a library that has a function called sync, and if you override that function, then you can do whatever you want to sync your data with the back end. So we're doing that over the event bus in ballot.js, and I just rewrote all of this stuff like 10 minutes before the demo, so that's why we that's why we're seeing things like this. But we'll pretend that didn't happen. Okay, so we've got this event bus object that we can pull in using the Vert.X API, and we're going to do a few things with it. We're going to define a function that can read a collection using the event bus. The collection in this case is the ballot, the candidates, the number of candidates. So we set up a query using find. We can use some sorting and match specific data if we'd like to. And then we just send a message to the event bus on the Mongo address with this query saying, hey, give us all the candidates that you know about. And the function that we provide as our third parameter here is the function that gets called once that operation has completed asynchronously. If everything is okay, then we just iterate over all of the results. And we're going to register a change handler on each one of those records that we get back from Mongo, so that when changes are made on the model locally, we can be made aware of it and send a message to the event bus. Register change handler is here. All it's doing is saying, all right, for that given record, for let's say Buster Keaton, I'd like to register a handler for that record's URL. And the record URL in Backbone.js is typically looks sort of resty. It's got a kind of a server name. In this case, it's just demo.mongo / and then some sort of ID. We saw in the console that we saw all that stuff in the console. Let's go back over here to this console where things haven't broken yet. This is basically the event bus address that we're going to start listening to for each one of the candidates. I think this one's Buster Keaton's address. So that's all we're doing here is as we get data from MongoDB, we're locally saying, all right, well, I want to register a listener on that data, and when it changes, I want to update my local record. Then we have this function called publish model update. If the model locally has changed, I want to publish that message to the event bus. And all I'm going to really do is just send a JSON object that is the changed attributes, so votes, colon 10,000 or whatever. And then we construct a MongoDB query and send a message to Mongo over the event bus as well. Some utility stuff to convert things to and from Mongo and Vert.X. And then here is kind of the heart of it. Mongo Backbone is a function that takes the event bus, returns a function, and that function is the thing that we use as our backbone sync. Okay, so it's about 110 lines of what now appears to be broken JavaScript code. But really nice bit of functionality in those 110 lines, and this one should still be working, so we can play around with it just a little bit more if we want to. Bump up those votes a little bit. Now, the astute among you might have noticed that this is probably not very safe, not very secure. Basically, what I've done is opened up my database on the back end to anybody who knows how to construct the appropriate JavaScript query on the client side. Not ideal. So I'm going to leave that as an exercise for the reader. But before I do that, I just want to show you an example of how that can pan out. In this case, I'm a hacker and I've actually gotten onto your local network. Okay, so instead of doing this from a browser, it's just easier to show this way. But I've got a little script here. It's not doing a whole lot. It's just pulling in some Vert.X event bus stuff, and it's got this function called hack election, and it's setting a periodic timer for every second. Every second, it's going to execute this function called fetch and update. Fetch and update uses that Mongo query syntax to find all of the candidates named Buster Keaton, and it's going to start sending a query to Mongo every second saying, update those votes. Update votes function basically just looks at the existing votes and adds a small random number to it and saves it. And if we run this, it looks something like this. Hopefully I didn't break this one too. And you can see now I've hacked into the local network, and I can start sending things unimpeded to the event bus. And if we go back to our Mongo, we can look that Buster Keaton's votes are now up at 44 records. And if we go back here, we can reload this page, and oh yeah, I broke it, so we can't actually do that. But it would show up on the page if I hadn't been hacking it 5 minutes before the demonstration today. So anyway, that's kind of your quick and brief, oh, I know what it is, I turned off Wi-Fi. That's what it was, because it's got to pull down JavaScript from places outside of my local computer. Should have thought of that. So, okay. That's it. That's my little demo application. I hope that gives you a sense of the kinds of things that you can do with Vert.X. Obviously, what I was showing you was not big data, but there was Mongo on the back end. I think you can probably extrapolate from here and find ways to utilize this kind of asynchronous awesomeness to take advantage of the data problems that you might have. So, as I mentioned, it's really not secure. Some exercises for the reader, if you're interested in playing around with this, are things like security of the Mongo data. You don't want to allow anyone, especially from a browser, to be able to just write, read, delete, whatever they want to from your Mongo database. Minimize duplicate messages. If you were paying attention in one of those JavaScript files that I showed you, I'm actually sending 2 messages to the event bus for every update, one to update the browsers and one to update the Mongo database. Probably better to just send a single message. Yeah, okay, so things that you might want to do if you want to play around with this little demo application. Some pros and cons of Vert.X. I mean, an asynchronous, evented kind of environment is not really right for everything. You can't run Rails apps on this, for example. I suppose you could, but it would be lipstick on a pig or vice versa. I don't know. Wouldn't be a good idea, probably. As far as compared to Node.js goes, Vert.X has, I think, it has some different approaches in some areas. Node is very, very low level. And you think Vert.X is low level, Node is very, very low level in certain places. Vert.X abstracts some of that away from you. And also Vert.X's clustering is built in so that you don't even have to think about it. I don't know if you noticed, but when I ran that little hack, that little, the cluster node that hacked the votes, all I did was give it a clustered flag, and it was immediately, because it was on the local network, clustered with every other Vert.X application on the local network. And I think in that area, it truly excels above Node.js. So, number of pros and cons for you. If you're interested in finding out more about Vert.X, there's a lot of stuff online. Vert.X.io is the website. There's fantastic documentation there for every single API that's currently available, as well as sort of general overview stuff. Vert.X is sponsored by the Eclipse Foundation, so you can find the Vert.X source code. It's open source. You can find it under the Eclipse organization on GitHub. This presentation, and hopefully not the broken one, is going to be on, it is right now, on my GitHub account under Data.io 2013. There's a Google group for Vert.X, and you can find them on IRC, pretty active channel there, and the Vert.X project on Twitter. And that's it. Yeah?
So this looks pretty cool. What motivated this project to begin with? What were people unhappy with they started to do this? I mean, I can guess, because I see a lot of languages, and you can sort of write anything in any language you want and have all the data interact, but I just want to know.
I don't really know what Tim Fox is the primary author of Vert.X. I don't really know what his motivations were. He was writing HornetQ, a distributed messaging system for Red Hat many years ago, and left Red Hat, went to somewhere else, and wrote Vert.X. And I think that Node.js was still is a big kind of up and comer in certain areas, and I think he wanted to compete with that a little bit, do it better maybe. And Tim has a lot of experience with messaging, and found that a lot of the sort of messaging protocols that you're dealing with on a day-to-day basis have a lot of overhead, and there's a whole bunch of stuff that bunch of things that you have to think about that may or may not be relevant to your application. And his idea with Vert.X was to take everything and slim it down as much as possible. So the messaging over the event bus, there's no guarantee that delivery is, that it's going to arrive anywhere. But you can add that guarantee if that's something that you need for your application, in the same way that you can add guarantees on top of the very low-level network stacks that when you connect to a web server, it responds. So aside from that, I'm not really sure what his motivations were. He also likes to do things that are highly performant, and the performance of it is really pretty remarkable in some cases. Sure. Yeah.
In terms of the JavaScript client show, which was pretty neat, that you get the events back and forth. And you had to write something to integrate it with Backbone. Are there other bindings, like for Ember or Angular or something that you're aware of? That kind of stuff?
I just saw a tweet today about someone doing similar stuff with Angular, and in fact, that was next on my list. So now I don't have to do it. And the Backbone stuff that I did for this demo, I did it for this demo, so it's kind of hacked, and I wouldn't use it in production yet. Let me put it that way. So yeah, Angular, Backbone, and I think there's a couple of others that people are working on. There's a module registry, and I think if you go to Vert.X.io and poke around, you can find a link to the module registry, and you might be able to find some stuff there. Yeah.
You were saying that you wouldn't use it necessarily to host something like Rails, obviously because it's its own kind of heavyweight MVC platform. But to write a regular application, web-based application with it, is that still kind of taxing it still?
No, not at all. Yeah, no, I think it's just that Rails is built on Rack, and it's sort of like has been thought of from the ground up as a synchronous networking platform. I think Rack can run with event machine or something now, but you know, a Rails environment is typically thought of as synchronous.
Because the thing I was thinking was you're mentioning that each vertical, even if it's a worker vertical, runs within a single thread. And let's say you've got 20 requests for a particular query on Mongo or SQL or whatever you're going to do. So they block and they back up. Can you do, I mean, would you normally then cluster it on multiple nodes and that's how you get more throughput? Is that basically?
Yeah.
Okay.
Yeah, definitely. And you know, I mean, let's say you have a dozen Mongo worker verticals because you're doing some really heavy reads. You can do a send instead of a publish, right, in order to send a query to Mongo, and only one of those worker verticals will receive that request and respond to you, leaving all the other ones free to.
Dispatching, essentially.
Yeah.
Right? Multiplexing, so to speak.
Right. Hey.
The bridge support proxy server.
Does the bridge support proxy servers? No, there's well, I'm not sure what you mean. The bridge actually.
Usually the network, financial transfers are all proxied out. So if you have some hosted on the server, and then you just go back to the client, so they can be deployed, or they can be in a trail of their phone, or else.
Right. So the way the bridge works is it runs over sock.js, and sock.js has some kind of fallback mechanisms, so that ultimately, like if nothing else works, it'll just do HTTP polling. So yeah, I suppose it does support proxy servers in that way. Yeah.
It boils down to whether sock.js supports proxy servers.
Sorry?
It boils down to whether sock.js supports proxy servers versus workers.
Yeah. Yeah.
Just a nuts and bolts question for Sandy's sake. When you were tabbing from tab to tab and data was synchronizing, was that initiated by the client, or is the event bus actually able to send some sort of events down to the client?
The event bus it can work both ways. The event bus can send data to the client, or the client can send data to the event bus. What was actually happening here is, I should turn Wi-Fi back on so I could show you, but what was actually happening here is that as data was being changed in one browser, a message was being sent over the event bus to Vert.X saying, hey, this data's changed, inform all the other web browsers that the data has changed, and then it sends it out to the other web browsers. And then another message, this is where the sort of two-message thing came in, another message got sent to Vert.X to update the Mongo database so that that would be in sync.
Socket open to all web browsers that have connected, or somehow keep a fallback? How does that work?
It really depends on what the client's capabilities are. So it's, like I just said, it's using sock.js, and I think it uses WebSockets if it can, and then has a series of fallbacks till it eventually gets to basic HTTP polling.
So is that eventually a performance limitation in the existing socket, like finite time?
No, not necessarily. I don't think so. I mean, when we're dealing with the ability to handle 500,000 responses per second, that's concurrent, right? 500,000 open connections. I don't.
So it's 500,000 requests and received, not open connection.
Not staying open all the time. No. Right.
You think about a machine having a socket bound, but that's 64,000 clients concerned about that one machine, right? They have hardware scale.
Yeah, probably. And I wouldn't necessarily recommend just sort of willy-nilly throwing all your stuff out there on the event bus to clients. I mean, it's really powerful and can provide some amazing functionality, but you have to be careful, both for reasons of scaling, but also for security.
Is there a single JVM?
Sorry?
Is there a single JVM that you're referring to 500,000 second request?
Yeah. I think the Vert.X website has I mean, I didn't make those numbers up. Vert.X website has links to the latest benchmarks, I believe, and you can dig into the details of exactly how they perform those benchmarks. But it's comparing not just Vert.X, but Vert.X and Netty and Undertow and I don't know, tons of other stuff that also doesn't really fit into the same category, like Rails. I don't know how that really fits, but anything else? All right, well, thank you for your time. I hope I answered your questions, and if you have any more questions, feel free to shoot me an email or hit me up on Twitter.